Welcome to Working with Discrete Data Events. While we often set up CHOP networks to use references, there are some situations where it's beneficial to think about using discrete events to make changes to your network. Here we'll take a look at how CHOP executes can help us work with events. Let's go ahead and start by adding an LFO here into our network. We can make a few changes to our operator. Let's make sure that it's set to square and that our frequency is turned down to 0.25. Next, let's right-click on the output of our LFO and add a null chop here into our network. Let's also add a few other operators so we can start to think about what we might do here with the output from our LFO. Let's next add a circle top to our network. We can connect our circle top to a constant top. In our constant top, let's go ahead and change the color to red. We can copy and paste our constant. And let's change the color of this one to be green. Next, let's connect both our constant 1 and constant 2 to a switch top. And here we can pause to think about how we actually want to use the information that we have inside of our network. We might think of this particular type of top arrangement as an indicator. Here our switch top has a red or off value, and then we have a 1 or green value that might be useful for when we think about displaying information about whether or not something is on or off. Now, in many scenarios, we actually want to use our CHOP channels to make changes to parameters, but there are some occasions where it's beneficial to think about how we can target this parameter from many different channel operators, or to think about using other events inside of TouchDesigner to make these changes. In those scenarios, we often use CHOP executes. Let's head back to our null chop, right-click on the output, head over to the DAT family, and here we'll see the CHOP execute DAT. Let's add a CHOP execute DAT into our network. The CHOP execute DAT allows us to run a little bit of Python code when a change happens to our channel operators. Here on the CHOP execute, we'll notice that there's a parameter to specify which operators we want to watch. We have a parameter to specify which channels we'd like to watch, and then we have a different set of callbacks that we can turn on or off. Now, it's important to make sure these are toggled on to appropriately match which callback you'd like to use. In our case, we're going to use the value change callback. Let's go ahead and make our channel operator, or make sure that our channel execute DAT is ready to edit. We can make it viewer active with the viewer active button in the lower right hand corner, and then we can author our Python code here directly inside of the CHOP execute DAT. What we'd like to do is we want to target the switch 1 top, and then we want to change the index parameter. Let's click on the index parameter, and here we can see the name that we need to use when targeting this specific parameter. Let's go ahead and write a simple expression to change this parameter. We're going to target the operator, and in parentheses, we'll use the name of the operator, in this case, switch 1, dot par the parameter dot index. So the operator switch 1, the parameter of that operator called index is what we're going to change. We're going to set that equal to 1 if val, the incoming value from our changed channel, is greater than 0. Else, in all the other cases, we're going to give this a value of 0. All right, let's take a look and see what happens. We'll notice that when our channel changes to 1, our switch top changes its index parameter to 1. And when the channel goes to anything but 1, our parameter changes as well. Now, one of the challenges here is that we don't necessarily see right away this particular connection, which can be frustrating and can cause problems for us in our networks. But there are also many scenarios where it's beneficial for us to be able to actually make this change without necessarily needing to connect it to a channel operator. Let's take a look at what that type of circumstance might look like. Let's go ahead and add an audio play channel operator here into our network. The audio play chop is very helpful for whenever we want to trigger audio that's just a single audio sound. This might be something like feedback that an operation is completed or just a simple sound effect. This is a great little tool to be able to use. It's an excellent operator, but there are some challenges to think about. So we could think about, well, maybe what we'll do is we'll just use a button component, and our button component can be hooked right up here to our trigger. If we make our button viewer active, that seems like it works just fine. We do have to toggle our button on and off, and that's okay. We could work with that. We could change the button to momentary, and in this case, what happens is that we need the audio to complete before we release our button. There are some other ways that we could think about this. So let's go ahead and take a look at what might happen if we used a chop execute instead. Let's go ahead and connect a null chop here to the output of our button, and let's add a chop execute here into our network. We can right click on the output of our null, head over the DAT family, and grab a chop execute. All right, so what do we want to do? In this case, we want to watch for a value change of off to on. We can turn off this value change callback since we don't need this one anymore. What we'd like to do is that when this channel changes, over on our audio play, we'd like to pulse this parameter. So in this case, we could write a little simple bit of Python that says op, the operator that we want to target, then in quotation marks, the name of the operator, audio play 1, the parameter, in this case, the parameter is called trigger. And here we want to pulse this parameter since this is a pulse type parameter. Now what we should see is that when we click our button, we've triggered our audio to play. One of the benefits of using this approach is that maybe we have multiple buttons that are going to use this same audio play mechanic. In this case, we don't even need to add another chop execute. We can instead just specify which other channel operator we want to watch. So here we also want to watch our channel operator called null3. Now, either button will trigger our audio. Finally, let's take a look at one other operator that we might want to use. Let's go ahead and in this case, let's add a timer chop here into our network. Now, in some scenarios, we might want to think about, maybe the end of a timer is the thing that might also trigger this audio to play. And in fact, we can take advantage of the timer's callbacks to help us with that. Let's go ahead and open up the timer's callbacks. We can do that by clicking on the docked timer callback DAT at the bottom here. And let's take a closer look. We can make our callbacks viewer active or make our DAT viewer active with a viewer active flag. And let's scroll to the bottom here. Here we see that we have a callback called onDone. We can use this onDone callback as this will run at the end of the timer. We can actually write just the same little bit of Python that we wrote over here. And in fact, we could come over to this operator. We could copy this and let's go ahead and paste that here right in the onDone callback. In our timer chop, let's go ahead and turn down the length to say something like 5. Excellent. Now let's go ahead and start our timer and see what happens when it gets to the end. Our timer is going to run for 5 seconds, and at the end of our 5 seconds, we should hear our audio play. Excellent. So our benefit here is that we're now able to use this one audio play channel operator, and we can target it from any number of other operators that might also need to use it. This is a great way for us to use fewer operators and to take advantage of the fact that we can learn a little bit about how to write some Python.